Greetings, everyone. Welcome to the 240th session of the online Optom Learning Series OOLS. And for today's session, we have with us Dr. Mera Haddad. Dr. Mera is an associate professor of the optometry at the Jordan University of Science and Technology in Jordan. She has completed a Master's of Science in the category of the Investigative Ophthalmology and Vision Sciences at the University of Manchester and went ahead to pursue her PhD from the same institution as well. Since then, once she returned back, she has been a lecturer in optometry and also a clinical supervisor at the Jordan University. She has done a lot of collaborative work, specializing in the areas of contact lenses, ocular health, contact lens materials, and lens surface properties. With that all experience, today she is going to share with us about surface properties of contact lens wettability and deposition. So welcome, Dr. Mera, onto our platform. And, let me just leave the screen time to you, please.
Good morning, good evening, good afternoon, good night, in case you're going to go to bed after this talk. I'm very happy to be on this platform and to share my expertise in the area of contact lenses. I work at Jordan University of Science and Technology. This is my institution where I have been working for 14 years now. We do lecturing optometry students, second and third and fourth year, and we do some clinical supervision. We have a small clinic at the university, but the main clinic is outside campus, where we teach our optometry students. And of course, we do research. My area of expertise is obviously contact lenses. I did my PhD in contact lenses. We do research on the materials, on the properties of, and we do some like ocular diseases and ocular surface and corneal surface and ocular surface health as well. Today, I wanted to talk. I will share with you some talk about the contact lens materials and properties as well. And why do we need to talk about lens materials? Because the contact lens market, as you all know, it's growing now. There is a demand from the customer, demand from the manufacturer, and it is growing really well. So people need contact lenses for correction, to correct the refractive error. Some are using them as therapeutics, and some just want to color their eyes, so they use cosmetic contact lenses. And there is the demands for contact lens users. They want a comfortable contact lens. They want a durable contact lens, and of course, they want a stable vision and comfortable wear during wear, I mean. And the demand from the contact lens manufacturer as well, they care about the market of the contact lens. They care about the ease of production of these lenses to provide it to their customers. So these demands guided scientists and to develop new material and to pay attention, or more attention even, to lens material. This is the market. If you see from 2018 to 2030, the market is growing. The market of contact lenses is growing, and that's a good thing. People are just heading toward contact lenses more and more. And of course, the revenue is increasing as well. So just to give a bit of material development, I'm sure you're all aware of the material development through the decades, through the years. So it started in 1930s with the glass sclerals, and then it wasn't a good option in glass. So people replaced it, or manufacturers replaced it, with PMMA, polymethyl methacrylate, and it was a very good material, giving excellent optical clarity, and it was easy to manufacture for the manufacturers, but the problem that it was non-oxygen permeable. So it didn't allow any oxygen to go to the cornea. So that's why the like complications were increasing, and people wanted a substitution for this material. So rigid gas permeable were developed in the 1970s, and these are still rigid materials, but they allow more oxygen to go to the cornea, so preserving corneal health. And then was the era of soft lenses. We have soft hydrogel contact lens and then the silicone hydrogel. In the 1960s to 70s, HEMA, which is hydroxyl ethyl methacrylate, was the most popular soft contact lens, and it was great. They call these lenses soft hydrogels because they are hydrophilic contact lenses. They have water, they preserve water, and they allow oxygen to the cornea. And they depend on water to provide the oxygen. Now, people were greedy at that time because they wanted then, if we have these lenses and they are comfortable during wear, so why don't we sleep with them? But sleeping with hydrogel contact lenses created a lot of problems because the oxygen allowed to the cornea through these lenses was not enough to overcome problems due to hypoxia during sleep. So that was a demand to increase the oxygen. And they increased it this time, not with the water, with increasing water, but they developed a new material, which is the silicone, because the silicone, the solubility of oxygen in the silicone is very high. So they incorporated silicone in the contact lenses, in the hydrogel contact lenses, and it became a very good lens. They created a very good lens with excellent oxygen permeability. So it allowed massive amount of oxygen to the cornea. So we have conventional hydrogel and silicone hydrogel. The conventional hydrogel, they are water swollen hydrophilic polymers, and they have good clinical performance, but they provide oxygen depending on the water content. Silicone hydrogel, they provide excellent oxygen permeability, but they are not without any problems because it allowed oxygen to the cornea and excellent amount, but the silicone in its inherently is hydrophobic. So it is hydrophobic, so it will create other problems like roughness of the surface. So the surface of the lens will be rough. It's hydrophobic, which means it repels water. It doesn't like water. So they created problems with a property called wettability, which is a term that we need to elaborate more in this talk. So after this problem, they paid attention, scientists and manufacturers as well, they paid a lot of attention to the properties of contact lenses. So I'm sure you're all aware, but it's just to refresh your minds about the properties. We have bulk properties, which are the properties inside the material, and we have on the surface of the contact lens. These are the surface properties. So the bulk material like water content, oxygen permeability, modulus of elasticity, and optical clarity. Of course, water content and oxygen permeability are very related to each other. So we have this famous graph to compare conventional hydrogel with silicone hydrogel. And to relate, it highlights the relationship between water content, equilibrium water content, and decay. If we see here that the squares are for hydrogel contact lenses. Hydrogel contact lenses, they depend on water to provide oxygen to the cornea. So the more water you have in the lens, the more oxygen it supplies to the cornea. Unlike the silicone hydrogel lenses, which supply oxygen to the cornea without depending on the water that the lens contains. Now, we see here, we have a lens with a maximum, with the highest water content, 90%. It doesn't even give, it only gives like about 75 barer, which is the decay unit. And this is not enough for extended wear. With the highest water content, we don't get enough oxygen to sleep with the lenses. And also, we can't do a hydrogel lens with this amount of equilibrium water content. It's impossible from the manufacturer and from the clinical performance point of view, because this lens will be very difficult to handle. This lens needs to be very thin, very, very thin, and we can't do this much of water with thin lenses. So they replaced it. Imagine here, if we compare it to silicone hydrogel lenses, with the minimum water content, it gives 150. It's okay if you don't understand the unit. It's just compare the numbers. So this is with the maximum water, it gives only 75, and this is with minimum water, it gives 150. So silicone hydrogel definitely solved the problem of hypoxia or hypoxia-related problems. Going back to the modulus, maybe you know it's related to the rigidity and stiffness of the material. So we have conventional and silicone hydrogel again. The hydrogel lenses, they have low modulus. The silicone hydrogel have high modulus, so they are stiffer. Modulus, it is very important in the durability and the ease of handling, so how to handle the lens. If you ever experienced, if you compare hydrogel with silicone hydrogel, and you had to touch them, of course, when you fit contact lenses, you will notice the difference that this material, silicone hydrogel, are stiffer than high. That's why they are more durable than hydrogel contact lenses, and people like it because it's easy to handle. And then optical clarity. This is again a bulk property of the contact lens. It provides it's related to the clarity and the transparency of contact lenses. And then we go to surface properties. Surface properties have gained a lot of popularity in the last decades because they are very important. They affect the interaction of the lens with many surfaces. And this is what we will talk about it. And this is at the end, of course, affect the clinical performance of the lens and again, the patient comfort. Now, surface properties, we have two surface properties. They are very related, as you will see now. We have wettability and deposition. Let's talk about wettability. Wettability, it's not a term specific for contact lenses. Actually, it was adapted later for contact lenses. They use it in chemistry, they use it in physics, because it describes any liquid spreading over a surface. So if we have a flat surface in chemistry and physics, they use it over a flat surface. It's not a curved surface like we have in contact lenses. So for flat surfaces, any drop of liquid, they put a drop of liquid and they watch the drop of liquid, how it spreads over the flat surface. If the water spreads well over this surface, the surface is said to be wettable. If the drop, we put it and stays as is, it doesn't go, it doesn't spread, the surface is said to be non-wettable. So, in physics, they use it, as I said, on flat surfaces. And the gold standard to measure this spreading, they don't just watch the drop as it spreads. No, they have a measurement. A measurement is the contact angle. So they put it on this surface and they see the contact line between the three interfaces, which are air, and then this is the liquid, and this is the solid surface. Contact between the three interfaces, they call it the contact angle. And the contact angle is the gold standard to measure wettability of any given surfaces. If we apply this to contact lenses, it describes the spreading of the tear film over the contact lens surface. So as the water spreads over the flat surface in physics or chemistry, we describe it in contact lenses. It describes the spread of the tear film, which is over the lens surface in the whilst on eye, of course. Now, the wettability governs the interaction of the lens with the tear film. And it governs as well how it governs that, because a wettable contact lens or a successful contact lens, if it's wettable, it supports a stable tear film. And a stable tear film leads to many different things, leads to good vision, good clinical performance, and good comfort, and patient comfort as well. In addition, it governs the interaction of the lens with the eyelid as well, because a stable tear film, again, which is provided by a wettable lens lead to a stable tear film, and a stable tear film leave a smooth area for the lid, which moves over the lens for thousands of times during the day, during blinking. So wettability is a key determinant of the clinical performance of the contact lens whilst on eye. Now, deposition, on the other hand, is very related to wettability. So a wettable surface, it should be less it should be deposit resistance. Deposition is the deposition of many contaminants, either contaminants from the tear film or components from the tear film, environmental contaminants, or even the lens care products. Sometimes they deposit on the lens. So you see how the images contain lens deposits, and it's very bad. It's very bad for vision, and it's very bad as well. Some researchers found that they cause immunological reactions. So they cause allergic reaction, they cause infections and inflammation. So depositions are not good. And when the lens is on eye, many things can deposit on the contact lens. Now, deposition and the tear film, if we reflect our minds about the structure of the tear film, it's a laminar structure. So we have lipid layer, and then the aqueous layer, and then at last mucin layer, which is touching cornea. So this tear film, the quality as well as the relationship between the three layers is very important, and it affects the stability of the tear film. Now, what components can deposit from the tear film on the lens surface? We have lipids, we have proteins, and we have many other components in the tear film. All of these components can deposit depending on the lens material. Now, it is known, according to research, of course, that hydrogel lenses deposit more protein, whereas silicone hydrogel deposit more lipids. This is a well-known after many studies have been done, especially in Canada. So it is the formation. Now, the problem with deposition is that if the deposition keeps building up on the lenses, it becomes denatured. And these multiple layers of denatured component, denatured proteins, denatured lipids, it is the one that affect the stability of the tear film. And they are very bad because this is from my own experience. We tried once a contact lens, which I can't say the brand, but it was very bad. But it's from the older generation contact lenses. Now, I'm sure all contact lenses are way better. But this lens, when we put it inside the eye, it directly deposits components from the tear film. You don't know how, so you just need to take it out. So it affects vision, it affects the clinical performance of patients. The lens, when it's inserted in the eye, you know that it divides the tear film into two parts. Some part go behind the lens. It's called the post-lens tear film. And the other part goes in front of the lens. If we see here is the brown line, this one, the surface is the contact lens. And when we put it in the eye, it divides this tear film into post-lens, pre-lens film. So the lens is wettable. It affects the stability of the pre. It should affect the stability of the pre and the post lens tear film. So, and this is what all manufacturers looking for or hoping for, that even with the lens inside the eye, it should support a stable pre and post lens tear film. Now, wettability and contact lenses, we can agree that a lens with poor wetting characteristic will result in a rapid break of the tear film. You know how the tear film, we measure sometimes the tear breakup time. So if a contact lens is not wettable, it will cause a rapid breakup of the tear film. And a rapid breakup means discomfort, means feeling of dryness, and means unstable vision. Okay. Now, wettability, we said it measures the contact angle. We measure it using the contact angle. And in vitro method, in vitro methods for measuring the contact lens wettability. In vitro means in the lab. So how do we measure contact lens wettability in the lab? We use different methods. First method is the sessile drop technique. Now, these methods are used in the laboratory. It's not on the eye, a direct measurement on the eye. So we take the lens out of the eye and we put it on this instrument that measures the contact angle. And if we see here, the sessile drop, it takes place in air. So we put a curved surface. This is black and white because the instrument make it black and white to enhance the contrast, so it can detect the contact angle. So this is a drop of water, and this is the contact lens. So we put the drop of water on the contact lens, and then there is either it spreads or it stays as is. In this case, in this picture, it's obviously. Then the instrument measures the right and left contact angles, and we take the average. The lower the contact angle, the better the surface, the better the contact lens, the more wettable the contact lens. So this is what we care about. Other technique is captive bubble. Captive bubble takes place, unlike the sessile drop, it takes place in water. So this is a amber of water. And instead of introducing a liquid, we introduce an air bubble. The lens is upside down. So this is the lens upside down, and we introduce a bubble, and it measures the displacement. Again, it's a contact angle, but it represents here the displacement of water by the air bubble. And again, the instrument, we don't need to do any measurements. The instrument measures the right and left contact angles, and we take the average as this measurement. The third technique in the lab is the Wilhelmi plate. This is, again, well-known technique, but it's not very much used as the sessile drop and captive bubble. Because it ruins a bit the contact lens, because we need to cut a flat or a bit of the lens from here and here, and it becomes like a plate, and we immerse it in water and we take it out of the water. And the contact angle in that case is measured as the force acting while the lens is dipped in the water and while it's taking out. So again, the instrument does all the measurements. You don't have to do any calculation. So in vitro methods, they are great. They give an indication about wettability, but they had many comments from researchers that they don't predict the clinical behavior. So if we put a lens in the lab, it's exactly or definitely not the same situation when it's on eye. So this is why they need clinical measurements to assess contact lens wettability. I did this. We developed with my colleagues in Manchester, we developed an instrument which measures the contact angle. So we adapted the sessile drop that you just saw. We adapted this method to an on-eye situation, and we had pretty good results. The sessile drop in the lab, and this is the sessile drop on eye. So we make the patient sleep, and we just introduce a drop of distilled water on the eye, directly on the contact lens, whilst the patient wearing it. But the color, this color, you will say not water. Yeah, it is distilled water, but it's colored with fluorescein, which is compatible just to color the drop. So we are able to see it. We had quite good measurements of contact lens, and they indicated they were different from for different contact lens material. But unfortunately, we didn't go further with that technique. So this is the contact angle. So this is, sorry, it's here. It's this image. So we put this image in the instrument that we measure in the lab, and it detected the contact of angle, the angle of contact between the three surfaces. So we measured the right and left, and we had an average contact lens. We didn't go further with that technique, and it wasn't like developed into a practical thing to use in clinics. So we depend now to measure wettability for you as practitioners or students later. For you to assess wettability, you can use the best instrument, which is the slit lamp biomicroscope. The slit lamp, using the slit lamp, you can assess wettability using different ways. So first, you can measure the tear breakup time, and I'm sure you're all aware of the tear breakup time, how you measure it, and you can measure it again with the fluorescein as well. So you measure the time between the last blink and the occurrence of the first either spot drying film or streak drying like one. When they appeared, you stop counting, and this is the time. Of course, the longer the tear breakup time, the better the lenses. The shorter breakup time indicate a problem with wettability of the lens, okay, or the tear film characteristics for the patient. Now, so this is the you see on a contact lens, the breakup time is sometimes really, really short. So it breaks on 3 or 4 seconds sometimes with us when we test it on the slit lamp. So here at 6 seconds, this lens was 99.6 breakup of the tear film. So it is important, and it is an important measure to assess wettability. There's another method using the slit lamp biomicroscope. It's using grading scales. If you are aware of grading scales for contact lens complications, there is a grading scale which is very good by the Core of Contact Lens Research in Canada. They developed a grading scale for wettability and deposition as well. So it goes from 0 to 5 for wettability, from 0 totally hydrophobic surface to totally hydrophilic surface, and it's equivalent to normal healthy corneas. Whereas the CCLRU grading scale for deposits, again, it goes from 0 to 4, and it provides the number of deposits, either absent deposits or severe deposition, which is number 4. We have this instrument. It was used a lot, and then it was discontinued, and now I see it again in the market. It is available. It's called the Tearscope Plus. The Tearscope is great because I used it actually with the contact angle measurement. It gives an indication of wettability by analyzing the lipid layer of the tear film. So it was developed by Michel Guyon, a French scientist, and Guyon described the tear film, the lipid layer of the tear film, and he pictured a different layer of the tear film, a different patterns of the tear film. For example, the open meshwork, if it appears like this picture, We call it an open meshwork, and it indicates a thin and very poor system. Whereas if we find it like this picture, we call it amorphous, and it describes a stable lipid layer, and it represents the best candidate to wear contact lens. So it's doing this, or it's assessing wettability by analyzing the lipid layer, which is very important. Now let's see what factors affect in vivo wettability. We have material properties. The material properties, it depends on the material. If it's hydrophobic or hydrophilic, wettability can be induced. Lens design also affect the wettability of the contact lens surface. Lens design, I just wanted to mention about silicone hydrogel. I mentioned in the beginning of the lecture that silicone is hydrophobic. Imagine the silicone hydrogel lens, if we take it and put it in our eyes immediately after manufacture, pure manufacturing, it looks like this. It's a rough surface, able to deposit, to attract deposit. This is why silicone hydrogel lenses, they do some surface treatment for silicone hydrogel because it is inherently hydrophobic. They improve the surface either by plasma coatings, or now companies, this was a while ago, plasma coatings, but now companies, they copolymerize it during the manufacturing process with wetting agents. So the wetting agents goes during the copolymerization process, so the lens becomes wettable and comfortable during wear. Otherwise, it can't be worn. Now, just to mention about the relationship between wettability and deposition, they described it in a way. They said that during interblinking, the contact lens creates non-wetting area on the contact lens. And these non-wetting areas, they attract hydrophobic component from the tear film or environmental contaminants. This is how wettability and deposition are well related. So one creates the other. If one is good, the other is good as well, or the deposit resistance. Lens care solutions also affect the wettability. We know they have preservatives. We know they have many components that may deposit on the lens and affect subjective comfort. And most importantly, the thing that affects wettability the most is the variation in tear film between individuals. So my tear film is different than yours, than yours, than yours. So no tear film, even if in one protein I am different than your tear film, it will be, you will react to contact lens wear different than my reaction. So it is very important to study the tear film. This is why we see now it's a hot topic, studying the tear film, studying dryness, because it's a problem. It's a problem. Why? Because although we saw the contact lens market growing, but on the contrary, there is a lot of dropouts from this. There are a lot of contact lens dropout. So people just stop using contact lenses and wearing contact lenses because they are not comfortable. Impact of wettability on contact lenses. We all agree now that high wettability ensures a smooth and a stable tear film. A stable tear film, we need it for good vision, good clinical performance, and good comfort at the end. And poor wettability does the opposite, obviously. Now, the addition, we can manage wettability sometimes by the addition of wetting agents. So all contact lens manufacturers, they add wetting agent to the blister packaging. So the first feeling of the patient when he puts the lens would be amazing. So this is because of the wetting agent. And some practitioners, here in Jordan and I hear some outside Jordan, they sometimes prescribe artificial tears with their lenses. Of course, it should be compatible with their lenses. So they use it and they prescribe it so the patient won't feel dryness and discomfort during wear. Impact of deposit on contact lenses, it affects comfort. As I said, it affects vision, it affects the health of the cornea. And you as practitioner, you can minimize the effect of deposit by choosing a good lens material. So silicone hydrogel are less prone to deposits than hydrogel lenses. Doing regular cleaning, advise your patient to do regular cleaning for their lenses, and they don't top up the eye, because the top up of the solution on the contact lens, you just top it up without cleaning, it builds contaminants, and they can deposit on the surface of the lens. The replacement schedule, do not overuse contact lenses. So we all know that we should be strict with the specified time towards them. So just to sum up, and in conclusion, I would say that surface properties, which are deposition and wettability, they significantly influence the interaction between the tear film and between the lens and the tear film, and between the lens and the upper eyelid, which should have, or which should find, a smooth surface to move with each blink. Otherwise, the patient will not be comfortable. We have laboratory techniques, the sessile drop captive, bubble, and Wilhelmine plate, but they do not usually correlate with the clinical performance, with the in vivo performance of the lens. Because, when you put the lens in the eye, it takes the temperature of the eye, it takes the characteristic, all the characteristics, or the media. It is in a different media than in a room or the lab. In vivo methods, on the other hand, they can assess the stability, and they concentrate on the tear film. So they assess the breakup time, they assess the lipid layer, and then we can indicate that the lens is wettable. If the tear film is okay and stable, then the lens is probably, or obviously it will be wettable. So choosing the right lens material and proper lens care can enhance user experience. Now, the future outlook, all companies and all manufacturers are making their efforts just to improve their lenses more and more. So they want just to reach the ideal contact lens. Until now, imagine from the 1930s, until now, there is no ideal contact lens. Because it's not just about wettability and deposition, it's about all properties of contact lenses. It's about the material of the contact lens. So it's very difficult to accommodate all these in one contact lens, but they keep researching, and research is always going on just to improve and develop a lens that would be comfortable with good clinical performance. Thank you very much. I hope the talk was enjoyable, and I hope I didn't go very long.
Thank you so much, Dr. Mera, for that wonderful talk, and revising again of what is the importance of material, because often in clinical practice we just talk about hydrogel, silicone hydrogel for short wearing hours, silicone hydrogel for long wearing hours, but there's more to it, right? So it's very important, right?
It's important to understand the science behind it, even if you are a practitioner and you just go to your practice and work. It's good to know the science, so you can later work on it to provide a good contact lens for your patients.
Right. Yeah. And now the challenge is there's so much available. I think choosing the best material plays a very important role, because there's so many new materials, so many different things being developed. So I think we play a very important role in that as well. The first question, Dr. Mera, was just asking about, we did talk about the properties of different lens materials, specifically for soft lenses. We talked about hydrogels versus silicone hydrogel material. So any recommendation of choosing lens material with respect to environment? Now, in this case, particularly is dusty environment, but if you'd like to add on, how would we choose material based on the environment where the patient wants to wear their lenses?
Well, usually in dusty environment, we don't recommend wearing contact lenses, but sometimes you are wearing it and you came across a dusty environment. Now, it is well known that silicone hydrogel are less prone to deposits than hydrogel contact lenses. But otherwise, you can just wear protective eyeglasses. This is how we usually, because whatever material it will deposit either environmental contaminants or them from the tear film. So the material which has good oxygen permeability, which provides a stable tear film, I think it would be a good option to wear. But you can't prevent these contaminants to go on the contact lens.
Right. Yeah, I think using protective glasses, as you said,
Yeah,
based on the
some
occupation,
people.
for example. Yeah.
Exactly. Some people work in dusty environment every day, so they have this. You just encourage them not to wear contact lenses at that time, or just wear protective goggles or protective eyeglasses.
Yeah. Great. Next one is looking at sports, for example. Is it better to choose hydrogel because they provide better quality and clarity of vision? Is that the reason, or would you recommend something else?
No, sorry.
Uh,
No, it's not because silicone hydrogel are very good and they are of good clarity. And hydrogel contact lens, they can deposit protein from the contact lens, from the tear film components. So it's not for sport only, either can goes, but for sport, you need to be careful with the type of sport. So, for example, with in swimming, for swimming, you can't wear either hydrogel or silicone hydrogel. If you wear contact lenses, you need to wear goggles. So it's not about choosing hydrogel because it's more clear. No, silicone hydrogels are very clear as well. So yeah, you can choose either, but you need to pay attention to the type of sport you're playing.
yeah. Okay, a couple of more questions. I think the next two are revolving around a similar thought. If we have patients with low tear breakup times, what properties will be the best to choose in terms of lens material? So, if you have a patient who has marginal dry eyes or tear quality is low, what would be your to-go option of contact lens material choice?
Silicone hydrogel, definitely. Silicone hydrogel or low water content hydrogel contact lenses. Unfortunately, there is a mistake for Dr. Fakhruddin. Sometimes it's mistaken that you need more water content to avoid dryness, but this is wrong. You need
The
low
other way
water
around.
content because the more water you have, the more evaporation you have, and then
Yeah.
desiccation of the contact lens. So either you choose silicone hydrogel, they provide a good, with tear breakup time, they provide better. This is from my own experience. I find it better tear film stability with silicone hydrogel or low water content hydrogel contact lenses.
Yeah. And the next question also talks about which material affects the tear stability the most and increases the risk of having contact lens induced dry eye. So, which hydrogel versus silica hydrogel again? Which one do you
Yeah, they
think?
are similar questions. So,
Yes. Yeah.
avoid for marginal dry eye, as I said, you need to avoid high water content hydrogel. So silicone hydrogel, because they provide more oxygen, they add to the ocular health, or the cornea breathe very well, and it has still water, but it's low water content, the silicone hydrogel. If you want to choose hydrogel contact lens, you can use low water content hydrogel, low to medium water content hydrogel lens.
Yeah, that is exactly the reason why all of these manufacturers are coming up with daily disposables as well
Yeah,
in the silicon
definitely.
hydrogel category, because those are very beneficial for
Exactly.
your patients with marginal dry eye.
True. So in terms of contact lens material, silicone hydrogel, and now it's even better with the daily disposable silicone hydrogel contact lenses.
That's right. Yeah. And any thoughts about, in terms of depositions, does daily disposables or daily suffer from deposition in people with high protein deposits? And what are your thoughts with regards to the deposition of
Yeah, this
proteins?
is a
Yeah.
very good question, this one, because they usually ask this question. Daily disposables, when they were created, they were for this option. They were to reduce deposition, to enhance wettability. You use it for certain hours during the day and then you discard. So it is very good for it is very good as a deposit resistance contact lenses. But the problem is that people do not comply with the rules. So they overuse sometimes with daily disposables. I find patients buy solution and they keep it. So daily disposable, if they are used correctly, yes, they can be deposit resistance because the deposition, it's not one layer of deposition that causes the problem. It's the buildup of deposits all over or during the wear.
Mm.
So if it doesn't have enough time to build deposit if it's a daily disposable, if the patient comply with the method of replacement, so that he discarded the same day.
Yeah, great. And we'll take one more question. We did talk about, measuring wettability, and you introduced the different tests in vivo as well as the in vitro. But is there any gold standard test which you think would be ideal to look at wettability of the contact lens material?
In vivo or in vitro? So
Probably
in
both is
vitro,
the, yeah.
both, yeah. In vitro, the gold standard is the contact angle. So this is
Yeah.
how they measure it in the laboratory. And we do actually, we now use it, until now, we use the contact angle as the measurement. And in all parts of the world, they use the contact angle as the gold standard measure for contact lens wettability in vitro. In vivo, mainly, you can consider it. I'm not sure if it's the gold standard, but you can consider the tear breakup time is the gold standard for assessing wettability in vivo. It's an easy and a quick test, and the patient doesn't feel anything, even if we put invasively with fluorescein. I don't think the patient will have to do. There are other measurements of assessing the behavior of the tear film. Of course, there is the tear lab, if you know, but the tear lab is not, which measures the osmolarity of the tear film. It's not available in all clinics. It's
Yeah.
not very available. So the easiest, the quickest, reliable method is the tear breakup time.
That's right. Yeah. And if you can do it non-invasively would be much easier. So rather than
Yes,
putting in any fluorescein and things like that,
exactly. True.
non-invasive would be better. Yeah. And I think last question, Dr. Mera, is about the material. So somebody wants to know what would be the ideal material you would choose if you are if you are fitting pediatric patients with contact lenses. And a similar question was regarding material when it comes to extended wear or continuous wear lenses. What would be the ideal choice? Will it be silicone hydrogel material, or do you have some other thoughts over it?
Yeah, definitely silicone hydrogel. For pediatric, they use silicone hydrogel, but to be honest with you, they have to be very careful, for pediatrics follow-ups, and we don't do pediatric patients. This is why my experience, I'm terribly sorry, but my experience is limited. So we don't fit pediatric patient, but you need to be careful. I think silicone hydrogel would be a best option, but you need to be careful with follow-ups because for pediatric, they sleep with the lenses and it increased the risk of infection. So, but regarding the material, I think silicone hydrogel would be best to sleep with the lenses.
Right. Yeah. Wonderful. Great. So with that, thank you so much, Dr. Meera, for sharing those thoughts and experience with us today. Yeah.
You're welcome. Thank you very much for having me on this platform. I'm very happy to share with you my teeny tiny experience in the field.
Yeah.
And I hope to meet you all someday face to face, not online.
Yes.
Thank you,
Sure.
Dr. Fakhruddin, for inviting me for this
My pleasure. My
session.
pleasure. Yeah. Until then, take care, be safe. We do have session planned over the next couple of weeks. Care and have a good day ahead. Bye bye.
Thank you. Thank you very much. Bye bye.
Thank you. Bye, Dr. Meena.